So starting with the algorithms first. Oh, sorry, logarithms. My bad, I wrote the wrong side. Logarithms. All right. So a logarithm, basically, I think like if you're familiar with the exponents, let's say we have a number 2 to the power 3, the answer would be 8 because 2 times 2 times 2, we get the 8. But let's say the logarithm do the opposite of that, right? So logarithm is the inverse for the powers, for the exponents. So the logarithm, if we do the log, let's say we have something, a number a whose power is b. So the answer is equals to something x, right? So then when we do the logarithm, the log tells us the log, this a goes into the base here, log a of that number x. The log of that number x is equals to b. For example, in this problem here that we have here, see 2 to the power 3 is equals to 8. So log with the base 2, and for 8, log base 2 for the 8 is equals to 3. This tells us that the power, what should be the power for the 2 when we do the logarithm? That gives us 8. So when the 2 to the power 3 will give us 8. So that tells us the powers, the exponents. And there's, okay, so, okay. And there's one more thing, we cannot do the logarithms, like you cannot put the negative number, let's say log ax equals to b. So x cannot be a negative number. And the reason for that is, like, no matter, because the powers, let's say we cannot get the negative as the answer, right? In x here, you cannot put the negatives.
Excuse me, teacher,
Yes?
that the
Yes.
student Stefan.
Yes,
Student Stephen, I
please.
need the repeat for the class.
Yes, I'm saying that we cannot put the negative numbers inside the logarithms, right?
Thank you.
You cannot get the like log 2 of -2. That's not possible. We cannot do that. So these numbers are always positive numbers. So let me go to the next page. Can I clear this? Can I clear my writing? Okay.
Yes, we're good, I think.
Okay. So there is some properties for the logs. So the first one is, if you have the two logs, log of two numbers, let's say they have the same base, right? Log a, the base a, which is called the base, and this is the number here, log a, log base a, b plus log a, have the same base. This one is the base, right? When they have the same base log, and this is, let's say, c, and when they are getting added, you can write them in a single log with the same base, and this b and this c, they will get multiplied. Right? This is the one of the properties that we have here. Then there is another one, which is about the divide. Like when we have the same thing, but the scenario is a little changed, there is a negative in between. All right. There is a negative here. Right? So these like the bullet. So we have, then we can write it again in a single log with the second one, the one with the negative sign, will be in fraction down there, will be dividing here. Then we have another good property of log, which says that, let's say we have this log and it has some power in here, let's say 2, or let me just write it in general. The power, let's say it has the power n. So this power n, it can be written in the start and everything else. Let's say, for example, if I have log 3 and there is 9 to the power 2, I can write it like this: 2 log 3 and then 9. So this power can go in the start, and it's two-way around. Like if it's in the start, you can also write it from this way to this way, or like both ways. You can do it, switch them both ways. It's two-way thing. All right. And there is okay, and there is another thing which is called change of base. Let's say we have the base log, let's say this is a and this is x. Sorry again. So I was saying, let's say we have log a and this is x. We can change the base of the log by doing, like, let's say we want to change this into base 10 instead of base a, we want to change it into base 10. So log 10 x divided by log 10 a. So log a, when we normally see the log on the calculator, wherever you see the log without anything written, just like on the calculator, that's normally log base 10. So if we want to convert any base into the log 10, base 10, we can do that formula. All right. X over 0.5 equals to log 3 5x minus 1 over log 3 and then 9. So let's start on both sides. Okay. So now let's start with this. So this 0.5, we can write it as 1/2. Two, right? And on the right side, we have log 3 5x minus 1. And okay, now the answer, we can solve this, all right? So log 3 to the power 9, you can use calculator, or if you know it yourself, you can just do it yourself. The answer for that thing is 2. Why its answer is 2? Because 3 to the power 2 is equals to 9.
La sala y me perdí un poquito de la clase.
The log is telling us that log 3, like what was the number when if we have the 9, what was this number here? So that's 2. Okay, you can use calculator if you don't know yourself. All right, so this is 2 here, and this 1/2, this 2 will, we can move this 2 up there. Get log 3. Oh, how is it
Roxana,
2?
Roxana, please mute Mateo
How is it
or
2?
Daritza. Daritza, are you there? Please mute
Because
Mateo.
log tells us what is the power. What is the power of 3 that gives us 9? That's what the log telling us, the thing. So 3 to the power 2 gives us 9. So that's why the answer is 2. So log, and then x, this 2 will go up in the fraction. So it will be 2x equals to log 3 and then 5x minus 1 over 2. Oh, sorry, this 2 is over the whole thing. 2 is over the whole thing. Then we cross multiply this 2 on the other side here. We cross multiply the 2 on the other side there. We get 2 log 3 2x equals to log 3 5x minus 1. Right, then this 2 is outside, so we apply the power rule. We will apply the power rule, and this 2 will go into the power here. Okay, so now there is one more thing. As I told you, the log is the inverse of the powers. Like if we want to cancel out a square, we do the square root. Similarly, if we have the same log with the same base on both sides, we log 3 and a log 3 here. If we have this kind of scenario, we can get rid of these logs by writing them, by taking the 3, by writing them in the power of 3. This thing, like the answer of this thing is actually just, they just cancel out each other. Okay, like power and the log 3, they cancel out each other. So what we will do, we will write the both sides in the power of 3. Because whatever we do on both sides of the equation, the balance do not disturb. We write both sides of the equation in the power of 3. So the balance is not disturbed. The equation is not disturbed. It's still same. So this log and the thing cancels out. So we get 2x squared equals to 5x minus 1. We can write it as 4x squared equals to 5x minus 1. So that's how we can solve this. We solved this logarithmic problem, and now it's just a equation. It's a quadratic equation. The quadratic equation is 4x squared plus 5x. Wait a second. It was 5x minus 1. So you move that to the other side. All right, and I assume that you might know how to factorize, or if you don't know how to factorize, you can use quadratic formula or quadratic equation to solve this. But you can factorize it by breaking it into minus 4x minus 1x plus 1 by doing the factorization. For factorization, we see what is the product of this number times this number, that is 4, and the sum should be -5. So the sum is -5, -4 minus 1 is -5, and when we multiply them, we get 4. So 4x squared, oh sorry, so we take out the 4 as common factor, 4 as a common, 4x as a common from these two. It will give us x minus 1, and then we take the 1 common from, actually -1 common from these two. It will leave us with the x minus 1. So we get 4x minus 1 and x minus 1. That will leave us, the first one isn't 4 times 2. Wait, sorry, Stephen, I didn't understand your question. We're not doing 4 times 2. No, this is squared. This is squared. X squared, not times. This is the power in the x. So then we write them equals to 0 separately, because when two factors are equal to 0, you can write them equals to 0 one by one. Then from there we will get x equals to 1/4 and x equals to 1. So that these are our two solutions for that question. Okay, so there is many other things, but like we have to cover 2 more topics, so we'll just move on. Okay, should I remove this? Can I go to next one?
Yes, Professor. Please go ahead.
Okay. So next one is complex numbers. Complex numbers. So the thing with the complex numbers is the idea starts from here. Let's say I want to do the square root of 4. The answer is 2. But if I want